some key take-home points. And then we also have a survey that we'd love to find out like who you are, and if you're interested in this kind of format, we'd love to get your information, or we'd love to just know who you are. So my name is Griselda Catania, and I am the co-director of Science in the News. Yes? So this is actually something that's biologists do, and that's a planet. So we're talking not just today we're talking about astronomy, but throughout we're going to talk about other stuff, cool stuff.
I'm Julia Brown. I'm the other co-director of Science in the News. And so today we have our first talk, right? Obviously it's about astronomy. We're combining it with Public Night, but you're going to have 3 graduate students, all PhD students from the astronomy department here at Yale, and they're going to be talking. Each of them is going to give about a 15 to 20 minute segment of this approximately hour-long, maybe a little less talk. And they'll be talking to you today about the anatomy of a galaxy inside out. So with that.
And when they're done, you can still either go to the planetarium show or
Thanks, guys. So, my name is Tommy Kao. I am a grad student here at Yale. I study astronomy. This is my 5th year. Yeah, this program is way too long. And it's not my last year even. Kind of depressing. But on that note, I'm actually really excited to be here tonight, just because it's always exciting to talk about what you do. Most of the time, nobody cares about what we do. Nobody cares about our research or our thesis and so on. So it's really exciting to have somebody who actually cares about what you do and actually listens to you for a whole hour. So I'm gonna, 15 minutes at least. Okay, fail number 1. There you go. Okay, so tonight I'm gonna do the first first introduction to kind of massive galaxies and astronomy in general. So I'm gonna cover the basic types of galaxies and what we see in the universe, or what we observe in the universe. And then Jedediah and Rachel will talk about the different components of massive galaxies, the outskirts or the overall stellar bodies of those galaxies. And then the supermassive black holes that kind of live in the center of every one of those galaxies. So to begin every astronomy talk, we have to ask ourselves. Go ahead.
What are the black holes?
So I'm gonna get there. Give me just a couple of minutes.
Wait, I know about the sun.
Oh, that's excellent. So you're gonna be able to answer my question in maybe 5 minutes. Okay? So we're gonna get there. Okay. So what do we see when we look up at the sky? So the quick answer is not much. And that's because we live in a very special place, and that's the Northeast. So when you look up at the sky, you don't see much. You don't see a lot of stars. You don't see a lot of anything, and that's because of light pollution. So what is light pollution? Light pollution is all the pollution that we create by facing some of our light, some of our man-made lights, to the sky rather than to the ground. And this will be a great point to actually bring your attention to the light pollution station that's on the other side of this wall. You can take a look at it afterwards. It's actually a great demonstration of why we don't see many stars inside when we are in cities, but even outside of cities, but not really far from them. So if you're in New York and you look up at the sky, you basically see that maybe one star up there, but not much. And then if you go out, and so this would be New Haven maybe, you'd see maybe a couple more stars. You may be able to spot, 5 or 6 stars. And then if you go out to, suburban Connecticut, you may be able to see a few more stars, but that's pretty much as good as it gets in the Northeast. And that's because all of the stretch from Boston through New York to DC, this is all one huge hub of lights. And when all those lights are pointed to the skies, or when a significant fraction of them is pointed to the sky, a lot of that light is bounced back from the atmosphere, from the air itself, and kind of shines back at us. So those stars are tiny dots of light with this huge projector right next to them. It's like putting a candle next to a huge stadium light. and trying to kind of see it. So it's going to be very hard. So we have to get really far from the stadium lights. And when you do that, you see many more stars, and well, there's Jupiter there, so you can see planets and everything. But if you go to really pristine observing locations, so as far as you can from civilization, basically, or if you somehow manage to convince everybody to turn off all their lights, you will see thousands of stars and much more. And one signature of the dark sky is this gorgeous band that kind of crosses the entire sky from top to bottom, and that's the Milky Way, which we all know, and I'm going to get to that in a second too. So, kind of just to see what we see, what makes up all of those points of light in the sky. Okay, so we do have some planets. That's true. So we do see some planets. So there are 8 planets. We can see 5 of them with the naked eye. That's a tough problem. Yes.
Why don't we see stars and planets?
So we do see them if we get far enough from cities. Okay. And so most of the points of light, most of the sources here that you see are actual stars. And maybe now you can answer my question: what is the nearest star to us? The sun, right? Exactly. So it turns out that a lot of these stars are actually a lot like our sun. The chemical composition or the makeup of what they're made of, in size and color, a lot of the properties of many of the stars that we can see with the naked eye are actually a lot like our own sun. But again, if you see the dark sky or the sky not from New Haven, you might see again this band of light, and you'd see that stars are not evenly spaced on the sky. Actually, a lot of them are concentrated along this band. And this band, as I was saying, is our galaxy. And why does it look like a star? It's actually not just a line. It's actually a flat disk-like thing. The reason why it looks like that is because we're inside of it. So you can think about it as if our Milky Way, our galaxy, is a pancake, and we're the chocolate chips inside. So as a chocolate chip inside the pancake, you won't be able to see the entire face of the pancake. You'll just be able to see kind of the thickness of the pancake itself. And just to demonstrate that, let's see. So this is our vantage point of the pancake. So we're the chocolate chip now, and we'll try to change that. We'll try to change our vantage point, and you see that. Well, now you can see the face of the pancake. Oops. Go back a second.
A pancake?
You're right.
Why did you say a pancake?
Yeah, I don't know. I like pancakes, especially chocolate chip pancakes. So you can see that, again, our galaxy, our Milky Way, has a very distinct shape. It looks kind of like a disc, or, sorry, I'm going to say it one more time, a pancake. But it actually is made up of a couple of different components. The 2 main components are, of course, those spiral arms. And this galaxy, this is, of course, not the Milky Way. We cannot observe the Milky Way from outside. But this is a galaxy this is a different spiral galaxy that looks a lot like the Milky Way. And it kind of helps me tell you something about those spiral galaxies in general. You see that the most prominent feature in those galaxies is, of course, the spiral arms that kind of wind up throughout the extent of the galaxy. And you might be able to see that there's actually the center looks kind of different from the spiral arms. And if again I change my vantage point and look at a different galaxy, now it's side on. Now I'm looking at the edge of the pancake. You see that again. So the spiral arms are along the disk, a very flat, very narrow disk, and there's this bulge which is a little different. And you can also see here that some of the light is being blocked by something, and that something is again seen here. So some of the light is being blocked by something that is a little darker. So these are the three components of our spiral galaxies. The spiral arms, which are blue, and the reason why they're blue is because they're made mainly of young stars. So in astronomy, blue means young and hot and energetic. In the center, which is the second component, the bulge, it's a little yellowish or even reddish, and that tells us that the stars there are older. So red is old and less energetic. And the third component is the gas and the dust that kind of obscure.
That looks like a pancake.
Yeah, no, not enough chocolate chips to, well, in my opinion. But the last component is the dust and cold gas, which kind of obscure light from the rest of the stars, and that tells us that there's ongoing star formation in those galaxies. Because to create more stars, to create new stars, you need that cold gas, and I'm not going to get into the details of why. But it's, of course, an interesting topic on its own. Okay, so again, you see here the three components, the flat disk, the bulge, and the cold gas that kind of obscures the rest of the stars. Okay, so if we zoom out of our galaxy and go to the local neighborhood of the Milky Way, you see that there are actually a bunch of galaxies here. And not all of them are, so some of them are very similar to the Milky Way. So here's the Milky Way with a few of its companions. And this is Andromeda, that we probably all know. And it turns out that Andromeda is actually very similar to the Milky Way. It's also a spiral galaxy, so this is the Milky Way as it can be seen from Earth. And this is Andromeda. You see again the spiral arms, the bulge, cold gas and dust lanes. But each one of those galaxies also has many companion galaxies. So the two satellite galaxies, or the most massive ones, or the ones that are at least easiest to observe, are the two Magellanic Clouds. And now you can see that this is a totally different kind of galaxy. The shapes are not quite this flat pancake that we've seen so far. And you might have said it many more times. Not on my side. Okay.